Yes, class. Am I audible to all of you? Sidra, Deborah, Rajita.
Yes, ma'am. Yes, ma'am.
See, in the last class, we started with current electricity yesterday. So we had completed few portions of it. We started with electric currents, basic definition, how to solve all the questions if it is duration is given, if we have mentioning of, if we have the mentioning of particular time instant, all these we had covered. Now, see, when we are talking about drift velocity, there was one relation at which we had stopped. We couldn't complete this, so I want to complete this first. I is equal to NEA VD. Now, see, details of this we couldn't complete. I is equal to NEA VD whenever you have. Look, class, for this relation, if you look at it carefully, I is equal to NEAVD. So how does it look like? It looks like when we talk about current and when we talk about area of cross section, both are directly proportional to each other. I is equal to NEAVD. Both are directly proportional to each other. I'll ask one question from Sidra. Sidra, you tell me, if I increase the area, will current increase or decrease? Current and area, they are directly proportional to each other. So increasing any one of them will lead to increment in the other or decrement?
Increase.
Deborah, your answer? Rajata, what do you think?
It will increase because they're directly proportional.
Okay. Now see, according to the formula, this seems like your answer is correct, Rajita, if it was directly proportional, right? This is what you had added also at the end. Class, problem is that it is not directly proportional. It looks like it is directly proportional. I is equal to NEAVD. In this formula, current and area, by the formula, if you look at the formula, you will think that this is directly proportional. So if you will increase the area, current will increase. If you decrease the current, area will also decrease, like this. No. See, area is fixed from where the current is passing. Area is fixed. An amount of charge which has entered, it will only leave. If one area, I'll give you an example, wait. Look at this. See, this is one end, which is a narrower end, A1. This is a comparatively broader end, A2. So whatever amount of current has entered from A1, it will only leave A2. I1 will in any ways be equal to I2. So that's why we say current is independent of the area of cross section. Why am I asking you to give emphasis on this? Because when you are giving your exam or when you are revising, it slips out of the mind and we tend to assume that because of the formula, current and area will be directly proportional. No. What matters is drift velocity is inversely proportional to area of cross section. If A2 is wider, A2 is greater than A1. So drift velocity, see, if area is less, lots of electrons will try to pass through it. So velocity will be very high. That's why. And similarly, if large amount of area is present, so electrons will move slowly because large space is present. So if A2 is greater than A1, drift velocity 1 is greater than drift velocity 2. This is the relation. So this is one important point which you should remember while revising. Write it down, then we'll start with Ohm's law. Now see, coming to Ohm's law. I hope you all have written this. Done or not? Yes, no, what?
Yes.
Oh. Please respond, class. Only one student is responding. This won't work. Now see what is meant by Ohm's law. Network issues. Okay, Deborah. Fine. If you leave, I'll understand them. It's okay. See, coming to Ohm's law. Ohm's law basically says that you are having a conductor. Conductor again, it means suppose this is a simple wire which I'm having and I'm taking a very small section of this and I'm describing this to you. So if quantities like pressure, quantities like temperature, these are remaining same. If there isn't any difference in these quantities, so we'll say that whatever is the potential that is applied because of the battery, it is directly proportional to the current that is flowing within the circuit. So we say at constant temperature and pressure, current through the conductor is directly proportional to the voltage. Now in mathematics, how do you remove the proportionality sign? We put an equal to with a constant, right? So here our Ohm's law's equation becomes V is equal to IR, where R is the constant, which we call as the resistance. We'll have a class on resistance today only. And V is what? V is potential difference. I is what? I is current. That's it. This is your entire Ohm's law. V is equal to IR, and this will be used throughout. Questions directly from Ohm's law are very less. Usually only question based only on Ohm's law are not given, but it can be given to you. What all types of question can occur, that I'll take. Firstly, you have to understand the graph. If V is directly proportional to I, then VI graph will be a straight line. VI graph will be a straight line. As soon as you'll increase the value of V, value of I will also increase. As you'll increase the value of I, value of V will increase. So both of them are linked to each other. So these values will keep on increasing. Now, R is equal to V getting divided by I. So whenever two things are getting divided in a graph, the third quantity, this third quantity is given by the slope of the graph. That is tan theta. So tan theta will be equal to V by I, which will give the value of resistance. Let's practice a question also based on graph. Graphical questions can come. Write this down, Ohm's law. Write down this question. I'll discuss. And though meanwhile, those who will write it first, share your answers with me in the chat column. The class using V versus I graph of two materials A and B, calculate resistance of A and resistance of B. So no answers by now. Look here, this is I versus V graph or V versus I graph. Can you notice this is your x-axis, this is your y-axis. So when I did draw the graph above, that was V versus I. This is I versus V. Now look, when I'm saying resistance of A or resistance of B, anything, resistance is equal to tan theta, which is equal to V divided by I. If it is I versus V graph, I cannot use this. It means I versus V will give me what? It will give me 1 over tan theta. That is, it will give me 1 by R. Do you understand this? This will give me 1 by R. So now see, tan theta will give me 1 by R this time for I versus V graph. So when I'm talking about resistance of A, this becomes 1 over tan theta A. Resistance will be reciprocal of it. All right, so resistance of A, this will be 1 over tan 30 degree. So the answer, which was supposed to be 1 by root 3, now only becomes root 3. Understood? See, resistance of A will be what? 1 by root 30 is what? Tan 30 is what? 1 by root 3. So 1 by root 3 will go above. So RA is root 3 ohms. Ohm is the SI unit for it. This we haven't discussed. Now we'll discuss this. Now, when I'm talking about RB, resistance at B, RB when I'm talking about. So this is 1 over tan theta B, which is equal to 1 over tan 60 degree. So RB will become 1 over root 3 ohms. So answers have exchanged because they have been reciprocated. Had our graph been V versus I, straight away our answer would have been direct value. Note down the solution. Now let us discuss resistance in detail, because right now we didn't. We have just seen and touched Ohm's law right now. Now Ohm's law will stay throughout with you. Everywhere you will be requiring Ohm's law. Now class, coming to resistance, what is meant by resistance? See, resistance basically means, yesterday we have studied about drift velocity. So in drift velocity, what did we see? We had seen that other other ions, other charges, other particles are also present apart from electrons whenever the current is moving, whenever the charges are flowing, right? So what happens? All these ions or other particles, they obstruct the flow of charges. They come in between the motion of electron and produce hindrance in the motion. So this opposition to the smooth movement of current is called resistance. How much, if there is a lot of current in flowing in your circuit, it definitely means that resistance is very less. That's why lots of current are able to move. And if I say a very little amount of current is flowing, it means there's a lot of resistance. This is one of the possibilities which can exist. This you can see through the formula also. If V is equal to IR, so R will be equal to V by I. This is according to Ohm's law. So R is equal to V divided by I. So R is inversely proportional to I. So more and more resistance, very less values of current. And high amount of current means very less value of resistance that is existing. Now, one relation we had seen yesterday, I is equal to NEAVD. It's a very important relation for your exams also. This comes as a 3-marker question. This derivation, it can happen that drift velocity's derivation is omitted, but I is equal to NEAVD, this relation between current and drift, it comes as establish a relation between current and drift velocity. This can come. And what is the formula of drift velocity? This also we had seen, minus EE tau by M. This part, both these derivations we have done, and both these derivations are important. Especially this one. It's short and it is usually asked in the exam. Now let us substitute the value of VD in this. I is equal to NEA. Instead of VD, let us put this value EE tau by M. I am excluding the negative sign because negative sign that depicts the direction that is opposite to that of electric field. Acha, one more thing regarding this electric field. Electric field is equal to minus dV over dr. Do you people remember this electric field as a change of potential gradient? E is equal to dV over dr. If I write this as V by L, this is electric field is directly proportional to the potential gradient. This means potential that is changing with respect to time. This is also very important. And at that time also when we were discussing, I told you this will come further also. This relation will come ahead also. It's very important relation. We had seen this relation in capacitance also, right, in the derivation of it. So let's put this value also. This is value of E. So I becomes equal to N. E into E will become E square A tau by M, and instead of this electric field, I'm writing V by L. Now, one thing I'll do, let me write this L together. L over here. Can you notice something? If I'm writing this, wait. V is equal to N E square A tau by M L into I. No, this V will be ML by. V will be equal to ML by NE square A tau into current. Can you just see a resemblance over here? V is equal to something I. We have just done a law. Can anyone tell me what should be this value equal to? V is equal to something into current. V is equal to this value into current. Very good, Anna. Resistance. Correct. This is actually resistance. V is equal to IR. This is Ohm's law, what we have studied. So R is actually equal to ML by A N E square tau. So first relation of resistance we have seen was V divided by I. That is one formula. Second formula is ML by A N E square tau. Now what are all the terms? R stands for resistance. A is the area of cross section. Area of cross section means, suppose a wire is there. If I'll just cut the wire like this and then I'll see it, That becomes the area of cross section. So area of cross section. N is number density, means number of electrons in 1 unit volume. In 1 meter cube, how many electrons are present? So this is number density. E is the electronic charge, which in the last class also we have revised, 1.6 into 10 to the power minus 19 of Coulomb. Tau, entire derivation we did, average relaxation time. Average relaxation time. L is what? L is the length of the conductor. How much area, how much is the length of the conductor through which electrons have to drift and cross? So this is length of conductor. And M is the mass of electron. Mass of one electron, 9.1 into 10 to the power minus 31 kgs. Now, on what factors this resistance is depending upon? Resistance depends upon, see, it is directly proportional to the length. It is inversely proportional to area of cross section. These we'll see. And it is also a proportional, and it also depends upon nature of material. This means, suppose resistance of copper I'm taking, it will have a certain value. Resistance of zinc I'm taking, it will also be having a different value, but that value will be fixed for it. Like density of water is something, density of oil is different, density of glass is different. Similarly, resistance is also a material dependent property. For every material, there is one value of resistance fixed, which can change, but for two materials, it's not the same usually. And then it depends upon temperature. See, first point, second point, and third point, you have numericals also that we'll discuss. This point, you just have to remember nature of material. All right, so this I'll discuss. Resistance is a measure of the opposition to the flow of current in an electric circuit, and the SI unit is ohms. Write down about resistance, then we'll see resistivity. See, so what factors was resistance depending upon? Firstly, it was depending upon length, and then it was depending upon area of cross section. Temperature, we'll see it separately, and nature of material is a theoretical point, so you don't need a formula for that, right? Now see, if I'll combine this, so R becomes directly proportional to L by A. Again, I'll remove the proportionality sign. I'll put an equal to with a constant. Here, the constant that comes is known as resistivity. This is what is meant by resistivity. Now, how will you define resistivity? See, if I put length as 1 meter and if I put area as 1 meter square, then can you tell me what will be the relation left in this equation? Length as 1 meters and area as 1 meter square. Yes, Fadil.
Yes, ma'am.
What will be the relation left? Rajata?
To be honest, I don't understand your question.
See, length, this is the equation, R is equal to rho L by A. Fine. This is till here, have you understood this, how we have derived this? We have just
Yes.
written the proportionality signs. Okay.
Yes,
I am saying if I put length as 1 meter, 1. Okay. And area also as 1 meter square means unit. Now what will be left in this formula?
Rho is left.
Rho is equal to R, right? So see, how can you now define the value of resistivity? Look here. You can say resistivity is equal to the resistance for unit length and unit area of cross section. This is how you can define it. Why? Because resistivity can also be written as R into A divided by L. Rho is equal to RA divided by L. So here you can now define, see, resistivity, sometimes we have to define the formula also. So how will you define this formula? You will define it by resistivity is equal to the resistance for unit length and unit area of cross section. Till here, is it clear? Rajita, clear?
Yes, ma'am, it's clear.
All right. Now see, we have derived one formula of resistance also. Remember, right now only, before that you people must have written it over here. ML by ANE squared tau. So let's put in here and see what is the value of resistivity we are getting. Resistivity is RA divided by L. So resistivity will be R is what? ML by ANE square tau. Now multiplied to area by length. See, the difference that will come in formula of resistance and resistivity. Length will be cancelled, area will be cancelled. So what is the formula of resistivity? Resistivity is M by NE square tau. I'm not writing what is the meaning of each symbol because these are same exactly what you have written. And SI unit of resistivity, see, SI unit of resistivity, we'll put it through this formula. What was resistance SI unit? Ohm. Areas SI unit? Meter square. Length SI unit? Meter. So this meter and square will be cancelled. So the unit is ohm meter. This is the SI unit. And what is the definition of it? Resistivity of a material is defined as resistance of a material of unit length and unit area of cross section. Write it down. Now we'll see some questions also. Numericals will start now based upon what we have studied. Percentage one we'll do first because lots of questions come from this relation in terms of percentage increment in this, percentage decrement in length, and like this. Write down, we'll see question based on that. See, here this question says that the wire increases by 2%. You have to find out the value of resistance and resistivity. See, in our formula, resistivity, area and length both got cancelled. So resistivity is material dependent property. For different materials, it will be having different values. Again, similar to resistance, like value for copper, value for brass, value for zinc, value for iron. All these will be different. But area and length, these are already eliminated from here. You can see length and area got cancelled. You do not have area and length in the final formula. So whether you increase the length by 2%, 5%, 100%, the resistivity will not be variable. It's like density. See, if you take a full bucket of water, the density of water there will be 1000 kg per meter cube. And even if you take one drop of water, it will still be 1000 kg per meter cube, because these are not, these are extrinsic quantities you must have done in your states of matter, extensive and intensive properties. So they do not depend upon how much quantity is present. It depends upon the nature of material. You change even that one drop of water to one drop of oil, the density will be variable. Understood? So that's why resistivity is independent of the material. So when it says no, calculate change in resistance and resistivity will be the same. Resistivity is independent of area and length. It depends on material. So resistivity, therefore, it will be the same. But resistance will be different. In our formula, we know resistance is equal to rho L by A. So there will be a new resistance, which will have rho L dash by A dash. L dash why? Because length, if you increase the length, area will decrease. If I'm increasing, so I'm stretching something, area will decrease. If it was thick, it will become narrower, area will increase. So length and area will be new. But since, as I have discussed, resistivity will be the same, rho is there already in our form. Now, what is the length? How much length is increasing? Length is increasing by 2%. So new length will be L plus 2 by 100 L. That becomes 102 L by 100, which is 1.02 L. So your length is L dash is 1.02 L. Now, how to find out area? Class, can anyone tell me, any one of you, apart from resistivity, when I am stretching the wire, if area is decreasing, length is increasing, one more quantity that will remain constant? Any idea? Anyone? Volume. See, if I have this much amount of wire, I'll extend it, volume will remain the same only. I have not added any material, or nor I have taken out any portion. So volume which was initially present will still be the same after extension also. Length has, see, in order to maintain and conserve the volume, if length is increasing, area is decreasing. If I take a thick wire and I am exceeding it, I am extending, it becomes narrower. Why? Because volume is there. The volume that was present initially is still remaining. So when I'm extending it, length, area has to decrease. Otherwise, it will break. So which quantity will remain the same? Initial volume will be equal to the final volume. This is initial volume, and this is the final volume. So how do we write volume? Volume is always written as area of the cross section multiplied to the length. Area of cross section multiplied to the length. So this becomes A, L initially, and finally you have A prime, L prime, the new length. So what will be the new area? We ultimately have to find out A prime. This will be A L by L dash. L dash is 1.02 L. LL will be cancelled. So value of area also we have. A length is 1.02 times L. New area is older area by 1.02. So now do we have the values, new values in terms of older values? Let's put the value. Let's find out R prime. We have L prime now, we have A prime now. So let's find out value of R prime. R prime will be rho L prime, L dash is 1.02 L. Area is, new area is older area divided by, so it will go up 1.02. Right. So that this becomes rho L by A into 1.02 whole square. So look, rho L by A is what? Rho L by A. This is the earlier resistance with which we have started rho L by A before extending the wire by 2%. This is that. So what is the new value of resistance? New value of resistance will be 1.040 R. Just check 1.02. I think it should be 1.0404. So R prime is this. Now what, this is the new value of resistance. We cannot stop our answer over here that it becomes 1.04 times. It is saying calculate percentage change. So how do you calculate percentage change? The change that has occurred divided by original. So how do you calculate change? Final minus initial divided by initial into 100 for percentage. This will give you fraction. By multiplying it to 100, you will get the percentage change value. So new is 1.0404 R minus R divided by R into 100. Let's take R common. So we are left with 1.0404 minus 1 divided by R into 100. R is getting cancelled, 1.104. This becomes 0.0404 into 100 equal to 4.04 percentage change. This is the final answer. Now one small trick that is just helpful for cross checking your answers, and students who have to appear for their entrances, for them this is helpful, but in your board exam you have to write the entire procedure the way we have done. This is just to give you an idea whether your answer is correct or not. If the percentage change is X%, resistance will be double. For example, in our question, length was changing by 2%. So finally, what did our answer come? Around 4%. So like this, you will have an idea whether you have done the calculations correctly or not. Fine. Note down the solution and please mark this as important. This question is important. You have lots of questions based upon this formula. See, this is a very easy question, but I have seen it repeating a lot in the previous year's papers. So that's why I wanted to discuss this. Value of resistance you have to find out. So resistance is rho L by A. It's just that we put the area of cross section, right? Area of cross section. So if radius is specified to you and you know the conductor is a cylinder, so you will automatically put area as pi r square. Fine, you will put the area as pi r square. So resistance will become rho L by pi r square. All right, write it down. One more question we'll see. One last question based on this resistance and resistance. Write down this entire page, then I'll discuss. Class, the solution to this question is third one. This is also very easy. It's just that you have to understand when we are defining the area, which two physical quantities you will consider, whether breadth into length, length into height, height into breadth. See, formula is R is equal to rho L by A. When I am seeing the first one, that is between 1 and 2. See, you have to know what are all the figures 1, 2. This is it. This is actually mentioned in the question only. So that confusion does not occur because drawing in 2D is different. That's why I have not written it earlier. Then this is 3, back one is 4th, above is 5th, and this is 6th. Now see, when we are talking about the first one, R is equal to rho L by A. So R is equal to rho, till here it's fine. When it is 1 and 2, what's the separation between 1 and 2? 1 and 2, this is like this. So when we are taking the separation between 1 and 2, look, this is the cuboid we have. So this is 1, this is 2. So what is the separation between 1 and 2? 1 and 2, they are separated by the length. This is 1, this is 2. You're talking about 1 and 2. So the length will be this L, rho L, divided by. Now what is the area of the cross section which you have considered? This is the height, this is the breadth, right? This is the height, this is the breadth. So this will become B into H. This is the area, this is the length. That's how. Second part says third and fourth. Third and fourth means this one, front and the back one. So front and back, how are they separated? They are separated by the breadth. So this becomes R is equal to rho B by. Now what is the area of cross section? This is length multiplied by height. So this is length multiplied to height. Fifth and sixth, front, above one and the bottom one. Top and bottom. So they are separated by the height. So this becomes R is equal to rho H. And what is the area of cross section above? See, above area of cross section. This is the length. This is the breadth. So this becomes length into. This is how you have to solve it. Write it down quickly. Any doubts if you have from this topic, let me know. This was the last question from resistivity. See, we have studied resistance and we have studied resistivity. These are now just 4 terms we have to do. These are very easy 4 terms. It's just that in your MCQs or in some numericals in between, you might be needing them. So that's why we are doing it. Conductance and conductivity, just inverse of resistance and resistivity. Conductance and conductivity. This is conductance 1 by R. So SI unit will also be ohm inverse, reciprocal of it. This is conductivity. Conductivity is inverse of resistivity. And SI unit is also ohm meter inverse. All right. One more term, that is current density. Current density means amount of current that is flowing per unit area. We represent it through the symbol J. Now these 4 topics, 4 small topics, 1, 2 we have done and 3, 4 we'll do. These are very easy, just formula you have to remember. So current density is current per unit area. It means amount of current that is flowing for a particular area of cross section. So SI unit will be what? SI unit is amperes for current, amperes, and for area we have meter square. So it's a vector, its direction is same as that of current. Current density, okay? You have microscopic form of Ohm's law, which says that it's a relation between current density, conductivity, and electric field. Current density, conductivity, and electric field. What are all of these terms? J is the current density. Sigma is what? Sigma is conductivity. E is the electric field. Fine. J is equal to sigma E. Last term that I was mentioning is mobility. Mobility is also very simple, very easy. You have studied electric field, you have studied drift velocity. Mobility is just the ratio of drift velocity by electric. That's it. VD is what? VD is drift velocity. And E is what? E is the electric field. So SI unit for drift velocity is meter per second. Electric field is Newton per coulomb. So this entire is actually the SI unit. So we write it as Newton meter per coulomb seconds. SI unit of mobility. That's it. These are 4 very easy terms, but they have significance for your MCQ questions, and in somewhere in the numericals it will be given. Entire question will be based upon resistance, resistivity, whatever you have studied, and instead of giving resistivity directly, it will give you conductivity. Conductivity in any ways is important, but conductance is not so important. Conductivity is very important. Conductivity will be used when we will be doing semiconductors also. So there also it is helpful. Write down all these points. Any doubts if you have, text me. Class completed. Now we'll do the rest of the portion. I have to do that resistance changing with temperature and internal resistance and EMF that I'll do on Saturday now. Okay, class. You people can leave.